Good evening everyone and welcome to my YouTube channel. So here today we are going to be looking at the dot product. So the dot product is also known as the scalar product. So the scalar product. So now under vectors, let's say we have the x or y plane like this. So we have the x, we have the y like that. So now under vectors we are going to be focusing on the three planes. Now for example, if we the dot product is also known as the scalar product. This is simply because a scalar does not have direction. So that means to say when you multiply using the dot product rule, you are going to have a pure number. Maybe your answer might just come out to be 5. It might just come out to be 6, not having any direction. So now we have introduced this x or y plane. Then under vectors we are going to have something that will have three planes. So like for example, it will look like this, something like this. So this is how we show the components that have got both the z, the x and the y axis like that. So these components will meet at 90 degrees like that. So therefore, now when you say that your x component is associated with the letter I. If you see the letter I, it means to say it is a component in the x-axis. Like for example, if you have a 2, let's say you have a 2i, it shall be shown like that. We can put a 2 here to show that this I is just showing it is just showing that we have a value in the x. If you have a, let's say the y component is associated with j. So if you just look, let's say for example you have 3j, it means to say you go in the y and put a 3. So this 3 and this j is showing you that it is in the y. Then when you go, let's say to let's just say that you just see a component that is 5k. So the z component is associated with k. So if you see 5k, it means to say it is a component in the z axis. So now with that knowledge, let us also understand something about the dot product. So the dot product, so if you look at I itself, it means to say already, if 2i means to say this is the size is 2. We were just getting 2 when we were plotting. We just get 2, we put it there. So this means that I has got 1 in front. So the magnitude of just the I component is just 1 already. So when you just see I, the magnitude, so this is the symbol for magnitude, should be equal to 1. So that's how come this rule stands. So if you have the dot products, which we are going to discuss more, let's say you have A dot B should be equal to our magnitude of A times the magnitude of B. Then we have times the cosine of theta. So this is how come, let's say now you are multiplying your I component times your J component. So your I times J component should be equal to, what's our magnitude? Remember, our magnitude of I should be equal to 1. So we are going to say this will be 1 times the magnitude of B, which is just a j. So this second part, not a cross j. We have I dot that. Then when we find the absolute value or the magnitude of just the j, this one is equal to 1. So times our 1, then times the cosine of, if you look at how we drew them, your x and your j will have 90 degrees in between them. So this means to say it will be 90 like that. So this means that we have a 1 times 1, which will be 1 cosine of 90. The cosine of 90 degrees will give you what we are going to call 0. Already, if you press on your calculator, cos 90 is 0. So 0 times 1 is just 0. So this is how come I times j is equal to 0. So as long as, in other words, as long as the components are different, like for example, if you have I times j, this we are saying that it is 0. If we have I times let's say k, which is the z component. This one, I, x components times the z component, it is equal to 0. Likewise, if we multiply the y component, which is j, times your z component, which is k, this one should also be equal to 0, like that. So as long as not multiplying, sorry, yeah, so we have something like that. So immediately we are looking at something like this. We can now be able to also look at what our I dot I is equal to. So the I dot I should be equal to, we have already established to say A dot B. This is our formula, which we are going to further understand. The magnitude of A times the magnitude of B times the cosine of theta. So I dot I will give you, so already we know that we have I dot I, like that, should be equal to our magnitude of I, as long as it's just a component like that. The magnitude of this one, the one is the one that is showing, so that will be your size. So it will be 1 times the cosine of. Now if this I dot I means to say both of them are in the x, axis, okay, are in one axis. Like let's say this is x, this is y, so they are both in one axis. This simply means to say we can be able to say that as long as they are in one axis, there is no difference in the angle. Therefore their difference in the angle is just 0 degrees. And we know that 1 times 1 is 1, the cosine of 0 is 1. So this is how come 1 times 1 gives us 1. So if you have I dot I, this one will give you 1. So now, to make a summary, as long as you have the same components, j dot j, this one should be equal to 1. If you have our I dot I, this one should be equal to 1. If you have the k, which is associated with the z dot k, should be equal to 1, like that. So let's say for our first question we have this. So how do you work out with this one? So in order, they are asking you, when you just see a dot like that, it simply means to say they are asking you for the dot product. So what we are going to do is we are going to say, in order for us to find A dot B, so we can say A dot B should be equal to, we are going to write this. So already A dot B, it's more like, think of it as if you are multiplying. So we are going to write what is our vector for A. It is our 3i minus our j plus our 2k. So this times we have our b, which is our negative I, we have plus 4j, like that, then we have plus our k, like that. So now already this means that there is, for A, there is 3 in the y, or 3 in the x, that's why we have I, negative 1. So in front we have negative 1 in the y and a 2 in the z. So now this means that if we also have this one, we have negative 1 in the x and also positive 4 in the y, and the coefficient of k for that one is 1, like that. So now how do we do the dot product? Now remember what we said. We said that I dot I is equal to 1. Then we have I dot j is equal to 0. So as long as they are different like that, it means to say you can have a 0. So now instead of us multiplying, let's say you multiply, because we know how to multiply. It means that we multiply this number, again after multiplying that we multiply this number, again after multiplying we multiply this number. That would be our first multiplication. Then after that we also get this one, we multiply this number, we multiply this number, we multiply this number. But we know that I times, let's say j, this is equal to 0. So we won't bother ourselves to multiply the one with the I with the one with the j. That would be a waste of time. So what are we going to do? So what we are going to do is this. Now we know to say already our A dot B shall be equal to, we have our 3. Since this is the I component, it shall be your 3I times your just negative I, like that. So this is what we are going to have. You just multiply the one with I, let it multiply with the one with I. The one with j, let it multiply with the one with j. So then after that, we are going to now multiply the one with negative j. Then we have times the one with our 4 j, like that. Then we are going to close like that. Then finally, we multiply the k's. Then this will be plus. So we are going to be showing whatever sign is there. So we have plus, plus. Then at the end, we are going to have our 2k. This is our 2k times our k, like that. So yeah. So we are going to have our a dot b should be equal to. So now when you multiply, this one is the same as, let's be using the dot product, the dots. So now dot itself also means multiply. It means to say you're multiplying those two. So this is the same as having our 3i dot. If we combine this negative times 3, it will be negative 3i, then dot our I. Then we are going to have our, this negative multiplies the positive, we are going to have minus. Then we have our 4j. Then this j is also multiplying, so we are going to write dot j, like that. Then we have plus our 2k. This k is multiplying, so we are going to have like that. So we are going to have negative 3. I dot I will give us positive 1. Likewise, j times j will also give us, j dot j, sorry, will also give us positive 1. Then we have k dot k will also give us positive 1. So we are going to have this. So we are going to get a negative 3 minus 4. Then we have plus 2, like that. So we are going to get a negative 7 plus like 2, like that. So this will give us a negative 5, like that. So this is our dot product. So if you have a dot b, this is what it is giving us. Now let us be able to find the angle between these two. So in order for us to find the angle between these two, we need to go back to our formula. So the formula for the angle that connects the dot product and the angle is a dot b should be equal to the magnitude of a times the magnitude of b times the cosine of theta. So where the angle between them is this theta. So how do you find the magnitude? So to find the magnitude of a, this is the formula we are going to be using. It shall be equal to the square root of x squared plus y squared plus z squared. So now our magnitude of a should be equal to the square root of, what's our x squared? So we are just looking at coefficients. So we are just going to get the 3 squared plus our y is equal to, so the coefficient of j here is negative 1. So we can put negative 1 in brackets. Then we say squared, like that. Then after that, we are going to have plus our z squared, which is this component. It will be a 2 squared. So this will be equal to the square root of a 9 plus 1. Negative 1 squared is 1. Then we have plus a 4, like that. So this shall be equal to, we have the square root of our 14, like that. So this is our size of a. Then let's also look at the size of b. So our b is equal to, so this is our b. So to find the magnitude of b, we use the same formula, square root of x squared plus y squared plus z squared, which will give us the absolute of b should be equal to the square root of, the x component here is negative 1. So we say negative 1. Then we have a squared. Then we have plus our 4. Then we say squared. Then we have plus our k, which is equal to 1. Then we square it as well. So after squaring these values, we are going to get a negative 1 squared gives us positive 1, plus 4 squared gives us 16 plus 1. So if we add 1 plus 1 is 2 plus 16, that's the square root of 18, like that. So this is how we find the size of B. So we have found the size of B. We found the size of A to be equal to the square root of our 14, like that. Therefore, we can now find the angle. Since the dot product A dot B should be equal to the magnitude of A times the magnitude of B times the cosine of the angles between them. So we know that our A dot B, the dot product which gave us A dot B, it gave us a negative 5. So we can just replace where there is the dot product, we put our negative 5. So we can say negative 5 should be equal to, where there is this, we have put negative 5, should be equal to the magnitude of A is equal to the square root of 14 times the magnitude of B, which is the square root of 18. By properties of radicals, we can multiply if both numbers are inside. So we can say 14 times 18. This will give us square root of 252. Here we have the cosine of theta. So we have negative 5 should be equal to 14 times 18. We can take one root and multiply 14 times 18, which is giving us 252. Then we have the cosine of theta. We divide this over the square root of 252 over the square root of 252, like that. So finding the direct answer, we are going to say, just pressing on our calculators directly. So first we have our negative 5 over the square root of our 252 should be equal to the cosine of theta. So we can take the cos the other side, it will become cos inverse of the negative 5 over the square root of our 252, like that, which should be equal to theta. So when we press this on our calculator, we are going to get our theta will be equal to, we are getting a 108.4 degrees, like that. So this is the value that we are getting for theta. So let's say we are told to find the angle between these two. We have our A and B. So how do we do that? The first thing, we know that A dot B should be equal to the magnitude of A times the magnitude of B times the cosine of theta. So we need to find the dot product, find the magnitude of A, find the magnitude of B, and then substitute. So our A dot B means you are going to say this should be equal to multiply A and B. So the vector A is this one, so it will be your 2i, then you have plus 2j, then you have minus k, like that. You multiply with the B, which is our 6i, then we have minus 3j, then we have plus our 2k, like that. Then just as we were doing things here, now we are going to go direct, since we already know. So our this 2 multiplies 6, since they are both i's. So our A dot of B should be equal to 2 times 6, it will be a 12. Then we move to this, our 2 times 3 here, this one is going to give us a negative 6, like that. Then finally our k, this last value with the last value, it will be minus a 2, like that. So our 12 minus 6 minus 2, this one will give us 4. So if we say A dot B should be equal to 4. After finding the dot product, we can find the magnitude of A. Our A is equal to 2i plus our 2j, then we have minus k. So to find the magnitude of A, we are going to say that this is equal to the square root of our x squared plus y squared plus our z squared. So we are going to get our A, the magnitude of A should be equal to the square root of our x is equal to 2. So we are going to say 2 squared plus our y is equal to 2 squared. Then finally we are going to have our we are going to have our plus our z component is equal to -1, then we have squared like that. So this one, the absolute of a should be equal to, we have 2 squared is equal to 4, plus 2 squared is equal to 4, -1 squared is equal to +1. So we are going to have the square root of our 4 plus 4 plus 1. This gives us 9. So the value of the magnitude of a should be equal to the square root of 9, which is equal to 3. So yeah, let's also find the magnitude of b. So to find the magnitude of b, we are going to say this should be equal to the square root of x squared plus y squared plus your z squared. Then this one will be equal to the square root of our x squared, which will be our 6 squared, since that's the x, plus our -3 squared. Then we have plus our z component is equal to 2 squared, like that. So this will give us the square root of 6 squared is 36, -3 squared is 9, then we have 2 squared is 4. So this 2 squared is 4, -3 squared is 2. So if we add, we are going to get the square root of our 49, like that. So the square root of 49 is equal to 7, like that. So this is the magnitude of b. So if we have everything, we can write a dot b should be equal to, we have the magnitude of a times the magnitude of b times the cosine of the angle theta. So we can just replace. We know that our a dot b is equal to 4 absolute of a, which is the magnitude of a is equal to 3, the magnitude of b is equal to 7. So we can be able to replace. So our a dot b is equal to 4, so we are going to put a 4 should be equal to the magnitude of a is equal to 3. So we put, where there is a, we put 3. Then we have times the magnitude of b is 7, like that. Then we have the cosine of theta, like that. So we are going to have 4 should be equal to 3 times 7 gives us a 21. Then we have the cosine of theta, like that. We divide over 21 over 21. We are going to get our so we have 4 over 21 should be equal to the cos of theta. So taking the cos this side, it will be equal to cos inverse of our 4 over 21. Immediately you take it the other side, it becomes cos inverse should be equal to theta. So when you press on your calculator, cos inverse of 4 over 21, it's given a 79.02 degrees. So this is the angle between them. So that is how you deal with those problems. So that is how we deal with those problems. Thank you very much for watching. If you like the video, kindly like, subscribe, and share for more. See you in the next tutorial.